Hi, my name is Matt, and today I'm going to show you how to evaluate a definite integral. In order to evaluate a definite integral, what you're essentially doing is you're taking the antiderivative of the function, then you're evaluating that antiderivative at b, and then you're evaluating that antiderivative at a, and you're taking the difference between those two. So, let's, for example, take the integral from 0 to 4 of 2 dx. So in this case, I'm going to call my f prime of x 2, because this is what we have in the definite integral. And so what you're going to do is take the antiderivative of 2, which is 2x plus c, and you're going to evaluate that at 0, and you're going to evaluate that at 4. So f of x is 2x plus c. So if we evaluate f of 4, we have 2 times 4 plus c, which is 8 plus c. That's f of 4. Now if I evaluate f of 0, that's 2 times 0 plus c, which is equal to c. So what I'm doing is I'm taking f of b, which in this case is f of 4, and I'm subtracting that from f of a, which in this case is f of 0. So f of 4, the integral from 0 to 4 of 2 dx is equal to f of 4 minus f of 0, which is equal to f of 4 we know is 8 plus c, and we know that f of 0 is c. And when we simplify, we end up getting 8. So the integral from 0 to 4 of 2 dx is equal to 8. And that's your answer. Now you may be wondering, well, why do I even need to do definite integrals? What does that do with, how does that serve me in mathematics? Well, taking the definite integral, what you're doing, one of its applications essentially is you're using it to find the area under the curve. So for example, in this case, we know that f prime of x is equal to 2. And we know that if we put this on, if we call this y-axis instead, we call it f prime of x, and we call this the x-axis, we know that f prime of x equals 2. So we know that that's going to be a straight line at f prime of x equal to 2. It's going to be a straight line. Now in this case, I said let's integrate from 0 to 4. So that's saying let's integrate 2 from x equals 0 to x equals 4. So if we end up doing that, what we're doing is we are finding this area right here. Well, we know that this area here, because it's a straight line here, we know that this is a rectangle. So if we know that the area of a rectangle is base times height. And so we know that the base is 4 and the height is 2. So we know the area equals 8. That's exactly what we got here as our answer when we integrated from 0 to 4 of 2 dx. So this shows you that evaluating definite integrals, one of its applications is finding the area under a curve, under the xy plane, or under a two-dimensional axis. So let's do another example. 0 to 3 of, let's call it x dx. So So you're doing the same thing. So what you're doing is you're taking the antiderivative of x. Well, we know that the antiderivative of x is x squared over 2 plus c. That's our antiderivative. I'm going to call x. I'm going to call f of x. I'm going to define x equal to f of x, or f of x equal to x. And so what I'm doing is so I'm going to say that I'm going to define the antiderivative of f of x I'm going to define the antiderivative of f of x as capital F of x. So we know that f of x equals x. Therefore, when we take the antiderivative of x, which is this here, we know that capital F of x is x squared over 2 plus c, because that's the antiderivative of f of x. So I want to integrate it from 0 to 3. So what you're doing is you're taking big F of x, which is your antiderivative, and you're evaluating it from 0 to 3. So what that means is you're evaluating x squared over 2 plus c from 0 to 3. So if we just plug in the values, so if we plug in 3 in this case, 3 squared over 2 plus c, that here is our capital, it's capital F of 3, because we're evaluating it at x equals 3. And you're going to subtract that from, take the difference, and you're going to evaluate this big F of x at x equals 0. So that's 0 squared over 2 plus c, which is equal to just c. So, and we know that this is capital F of 0. So we take the difference, and we know that 3 squared is 9 over 2 plus c, and we're subtracting that from c. The c's cancel, and you're left with 9 over 2 as your answer. So the integral from 0 to 3 of x dx is equal to 9 over 2. Well, let's use this application by finding the area under the curve. So if you have x and y, or in this case we'll say x and f of x, because that's what we defined y as in this example. Here we have x. Here we have f of x equal to x. And we're evaluating it from x equals 0 to x equals 3. Well, as you can see here, because this is a straight line, this is a diagonal line, and we're evaluating it from 0 to 3, you can see that this is a right triangle. Well, in order to find the area of a right triangle, we know it's 1/2 base times height. So if we do that, we end up getting 1/2 times the base, which is 3, times the height, which in this case, well, if f of x equals x, that means that when x is 3, f of x is 3 as well. So the height is 3, and we end up getting an area of 9 over 2. Well, that's exactly what we did in this example. We took the integral from 0 to 3 of x dx, the integral from 0 to 3 of x dx, and we found that it was 9 over 2, which is exactly the area under the right triangle from 0 to 3. So what you need to understand is that evaluating, one of the applications for evaluating a definite interval that I've previously said is you're essentially finding the area under a curve in 2 dimensions. And you might be wondering, well, why don't I always just use the area formulas and never take the integral? It seems easier. That's true. But when you have an example that's more complex, for example, let's say we have f of x equal to x squared, and I asked you to find the area between 0 and 2, well, you wouldn't be able to find the area by using a formula, because there's no formula for finding that from 0 to 2, because this is it's a curved function, and it's not a shape that we're familiar with. So in this case, we would have to use the definite integral to evaluate from 0 to 2. And so that's basically, when you get into more complex problems, you have to use the definite integral because, well, there's no area formulas for some functions that you have to evaluate or find under the curve. Or there's going to be some functions that you have to find the area under that frankly doesn't have a function or a formula for it. So just understand that when you evaluate a definite integral, that you're taking the antiderivative of that function and you're evaluating it at b, and you're evaluating at a, and you're taking the function that the antiderivative that you evaluated at b, and you're subtracting it from the function that you're evaluating at a, or the antiderivative that you're evaluating at a. So I hope this makes sense. This is my first video, so leave a comment if I made an error or if I misinterpreted something, and I really thank you for the comments, because you guys can only make me better by providing me advice and everything, and I wish you all the best and good luck with your math endeavors.